Hello children, welcome to AIMS India's live class session. So today from physics subject, motion topic we are going to learn. So this up to Saturday we are going to take class regarding the same topic, motion topic. And on Saturday we are going to have exam through our website or app regarding the same topic. So let's start our topic. Please inform your friends regarding the live class session so that they can follow from tomorrow. So, okay. So, rest and motion. So, rest and motion. Suppose here one boy is standing here, one vehicle is going from here, and one observer from here, he is looking the boy. So actually, for explaining the position or rest position or motion position of these two persons, we have to take the help of coordinate system. So actually, what is this rest and motion? So when a body does not change its position with time, we can say that the body is at rest. So we are having a object or we are having a body. The time is passing on. The time is changing. So half an hour passed, 1 hour passed. The time is going on. Still the body, before 1 hour, it is in what position? After 1 hour also, if it continues to be in the same position or it does not change its position, so then we can say that the body is at rest. The body is at rest position. The body is at rest position. Suppose if the body changes its position with time, then we can say that it is in motion. Then we can say that it is in motion. So the object, actually here all the objects, we consider them as point objects. We consider them as point objects. So how, if it changes its position by distances which are much greater than its size. If the change in distance is very great, so then the object we have to consider it as a point object. It as a point object. So normally in kinematics or in problems, we consider most of the objects as point objects only. So here, what is the meaning of point object? If it changes, if it change its position by distances which are much greater than its size, then we call it as a point object. So actually, how the body or point objects is changing its position. So for that, we have to take the help of a reference point or origin. We have to take the help of a origin or reference point. Basing on that only, we can tell that a body is changing its position. So for example, here, suppose this is the origin. This is the origin. This is the x-axis. This is the y-axis. This is the z-axis. Or we can call it as x direction or y direction or z direction. This is the origin. This is the origin O. So here, if we have to tell the body is changing its position, then how we have to tell? Based on this origin position or based on this reference point, we can tell that the body is moving. The body is moving. The body is moving in x direction. The body is moving in y direction, or it is moving in z direction. Either the motion of car or the motion of boy, we can tell they are changing its position or they are in rest position, or they are in motion position based on the origin, based on the origin, or based on the reference point, based on the reference point. So we can explain the motion with the help of origin or with the help of reference point. So here rest means there is no change in the position of the body with respect to time, with respect to time. So then it is called, that situation is called rest. So what is motion? There is change in the position of the body with respect to time, with respect to time. So while describing rest or motion, we have to take the help of time. With respect to time, we can tell whether the body is in rest position or the body is in motion position. Not only time, we have to consider this also. What is this? We have to consider origin. We have to consider origin or reference point, or this x-axis, this y-axis, z-axis, it is called as a reference frame. What is it called? What we call it as? Reference frame. So based on the reference frame or origin or reference point, we can tell that a body is in rest position or a body is in motion position. Okay. Any doubt regarding this? Regarding this rest and motion? If somebody asking a point object, if suppose we have taken a body, okay, here point objects means the two values, if they are not comparable, if the two values, if they are not comparable, then one value is considered to be point object when compared to the other object, because one value is very, very less and another value is very, very more, then one value is considered as point object. So next, motion. So here, a body is said to be in motion when its position changes continuously with respect to a stationary object taken as reference point. So here we are telling a body is in motion. A body is in motion. Or here, what is the example? Car. They have taken the example of a car. In this example, they have taken the example of a car. So here, the car is in motion. The car is in motion. So when its position changes continuously with respect to stationary object. Actually, when a car is moving, beside the car, in the surroundings of car, what we will come across? We will come across houses, trees, etc. or road, or persons standing on the road. Like that, so many stationary objects we will come across. Compared to all other objects, with reference to all other stationary objects, the car is changing its position continuously. So we can say that the car is in motion, because the car in the beginning, its velocity is 0 meter per second. It is on the ramp. It is on a inclined plane. It is on a inclined plane. In the starting position, its velocity is 0. It is not moving. But after 1 second, it is moving. 2 seconds, it is moving. 3 seconds, it is moving. Like that, finally, after 10 seconds, it will come to the ground and it will gain some velocity. It will gain some velocity. It will gain some velocity here. Suppose one observer is here. One observer is here. According to him, what is happening to the position of car? The position of car from 1 second to 10 seconds, with respect to time or with respect to the person, it is changing continuously. It is changing continuously. So we can say that the car is in motion. The car is in motion. Here reference point means for the observer, or for the car. For the observer or for the car, what we can tell, we have to attach some axis, x-axis, y-axis, like the coordinate axis we have to attach, or z-axis, coordinate axis we have to attach, or this point we have to take it as origin. This point we have to take it as origin. So with respect to this reference point, what is happening to the car? It is moving. It is moving. It is moving. Suppose we have a car here. Suppose let's take a car. Let's take any object here. Let's take any vehicle here. Suppose this is x-axis, this is y-axis, this is the origin, this is the origin O. Here, this car, if it is moving in this line, if it is moving towards this direction, means what we can tell, from the origin, it is moving in the direction of x-axis. So according to this reference frame, or according to this reference point, it is moving forward. It is moving forward. Here, reference frame means the frame attached to the either object or the observer. Either object or the observer. So here, this rest and motion are relative terms. Rest and motion are relative terms. They are not absolute. They are not absolute. So here absolute means it exists by its own or independent, not compared to anything, not compared to anything, or not related to anything. It is called absolute. Absolute means, what is the meaning of absolute here? Not related to anything or not compared to anything. Not compared to anything. It exists by its own, independent. These are all the meanings of absolute. So here relative means opposite to absolute. They depend on one another. They related to one another. So they do not exist independently. They depend on other objects or other things. We call them as relative terms. Here this rest and motion are relative terms. Rest and motion are relative terms. Why means a body may seem to be at rest with respect to one object, but may appear to be in motion with respect to another object. With respect to another object. Suppose if we consider our planetary system, we are on the earth. We are on the earth. So for us, what about earth? What is the position of earth? Because as we are standing on the earth, we think that earth is in rest position compared to the man standing on the earth. If man is the observer, and earth is the object, if man is the observer, earth is the object, so then according to man, he thinks that earth is in rest position. Earth is in rest position. So then what about if the observer is sun? So if the observer is sun, so then according to sun, what is the state of earth? Because around the sun, earth is moving in elliptical orbits. Around the sun, earth is moving in elliptical orbits. So according to, if the observer is sun, for him earth is not in rest position. So earth is in moving position, means earth is in motion. So the same object, here also we have taken earth, Here also we have taken earth. But according to man, it is in rest position. According to sun, it is in movement. It is in movement. So here, this rest and motion, they do not exist by their own. They depend on observer. They depend on observer. They depend on observer. As they do not exist independently, their position is compared to the observer. We call them as relative terms. We call them as relative terms. So if anybody asks, what is the position of an object? Is it in rest position or motion position? What we have to ask him, who is the observer here? Who is the observer here? If he tells the observer, according to that observer, we can tell either it is in rest position or motion position. Or suppose if you are moving on a train, if you are moving on a train, you are sitting here, your co-passenger is sitting in front of you. According to both of you, you are in rest. According to you, your front passenger, he is in rest position. According to him, you are in rest position. But what about observer who is standing outside? What about observer who is standing outside? For him, both of you, you are in motion. For him, both of you, you are in motion. So that's why these rest and motion terms, they are not absolute terms, they are relative terms. They are not absolute terms, we call them as relative terms. Why means they depend on observer. Why means they depend on observer. Okay. Any doubt, ma, regarding this? Regarding this, do you have any doubt? No moving, here somebody asking what is isolation. No moving object exists in isolation. No moving object exists in isolation. Means the movement of moving object, as we are telling it is moving. How we are telling it is moving? Basing on one observer. Based on observer, we are telling that it is a moving object. So, for telling, when we are telling it is moving, compulsorily the object is associated with the observer. Is associated with the observer. It does not exist by its own. It is not single. It is not single, or it is not alone. So that's why we are telling that no moving object exists in isolation. It is moving means when compared to one observer, it is moving. So that's why it exists along with the observer, not in isolation. Not in isolation. Okay. Any doubt? Okay, ma? Shall I go to next slide? Is there any doubt regarding this absolute and relative terms? Absolute means which exist independently. But here relative means which do not exist independently. It depends on others. Here rest and motion depend on observer. So that's why they are called relative terms. Okay. So next, types of motion. Types of motion. So according to directions, we have one-dimensional motion. We have some types of motions. In that, first type is one-dimensional motion. Means the motion of the particle will be along a straight line, along only one direction. That kind of motion is called one-dimensional motion. Next, two-dimensional motion. Two-dimensional motion means a particle moving along a curved path. A particle moving along a curved path or moving in a plane. Examples I will tell you in next slide. a particle which is moving in a curved path or a particle which is moving in a plane, they will show two-dimensional movement. Two-dimensional, they exhibit two-dimensional motion. Next, three-dimensional motion. Three-dimensional motion means particle moving randomly. What is moving? What is here randomly? Different directions. Randomly means not in one particular, changing continuously. Changing continuously. If the particle is changing its direction continuously in space, if it is moving in space, so then we call it as three-dimensional motion. Then we call it as three-dimensional motion. Okay, three-dimensional motion. Let's see the examples. So according to directions, we have three types of motions. One is one-dimensional motion, means moving in a straight line. Two-dimensional motion means either moving in curved path or moving in plane. Three-dimensional motion means moving randomly in space. Moving randomly in space. So here, one-dimensional motion. So see the car here. So how it is moving? It is changing its position from the point A to the point B in the direction of x-axis. Here, for the car, we have attached two axes. One horizontal line, one vertical line. So this is called reference frame. This is called reference frame, and this is called reference point or origin. Reference point or origin. According to this reference frame, the car is moving in the direction of x from a point A to the point B. Means it changes its position from A to B. It is in motion, but its motion is in straight line. Its motion is in straight line. So that's why this is an example of one-dimensional motion, because for telling its motion, we have to depend only on x-axis. Only, suppose here the x value is 2, here the x value is 10, here 2 meter, here 10 meter. So distance covered by the car is nothing but 8 meter. Is nothing but 8 meter. Means for finding the value of motion of this car, we are depending only on x-axis. Y means it is moving in a straight line, only along one direction. So this is example of one-dimensional motion. Let's see another example. A boy walking in a straight line, or a boy running in a straight line. It is also an example of one-dimensional motion. Okay. So next, two-dimensional motion. So here, see what the man is doing here. He is hitting the football. He is hitting the football. He is hitting the football. So here we are considering x-axis in this direction, y-axis in this direction, y-axis in this direction. So here the ball is moving like this. The ball is moving like this. Means it is moving in the xy plane, because here whatever place we are having here between x and y, this, because it is not moving on the x-axis, the ball is not rolling. If the ball goes like this, we can call it as one-dimensional motion, because it is rolling. It is rolling on the x-axis, but it is not moving on the x-axis. It is not moving on the y-axis. It is moving in the place between x and y. So in the plane between x, this is called xy plane, because if you want to tell the position of the ball here, we have to take the help of x-axis, we have to take the help of y-axis. So its motion depending on x-axis and depending on y-axis. So here its position, we can tell its position as x comma y. In maths, you might have learned this kind of points, x comma y. From the origin, what is the position of this object? If the x value is 2, y value is 4, the position of the ball after some time, we can tell it as 2 comma 4. Means for describing its motion, we have to depend on x value and we have to depend on y value. So it is two-dimensional motion. So this is an example of two-dimensional motion. Okay. So next, this is cannon. In the olden days, during war times, they used to make use of this cannon. Or in Bahubali film, you might have observed this kind of cannons for explosion of bombs. For throwing bombs, they will make use of these cannons. So a bomb released from the cannon, a bomb released from the cannon, suppose. So this is the x-axis and this is the y-axis. If we attach two frames, so then the ball is moving here, moving along like this. So the position of the bomb, if you want to tell, we have to depend on both x-axis and both y-axis. So that's why this is also an example of two-dimensional motion. This is also an example of two-dimensional motion. Okay, let's see. Three-dimensional motion. So here the kite, the flying kite is an example of three-dimensional motion, because the kite direction will be changing continuously. In previous examples, here the direction may not change randomly, though they are traveling in the air, but the direction as compared to kite, here it won't change that much randomly. So that's why, because the movement of kite is different compared to previous examples. Here the kite, it is moving in the space whose direction randomly changes in the space. So that's why for explaining its motion, horizontally how much it has moved, vertically how much it has moved through z-axis, because this xyz coordinate axis, they are mutually perpendicular to each other. For telling its exact direction along with x and y, we have to take the help of z-axis also. So with the help of x-axis, y-axis and z-axis, we can describe its motion. So that's why it is an example of three-dimensional motion. The motion of aeroplane, it is also an example of three-dimensional motion. So like this, based on directions, we have three kinds of motions: one-dimensional motion, two-dimensional motion, three-dimensional motion. Okay. So do you have any doubts regarding this topic? So somebody asking randomly. Randomly means changing continuously. Somebody asking, two-dimensional motion object will move in space. Yes, it will move in space, but compared to kite, its direction changes not happen that much randomly. So that's why we take it as a two-dimensional motion. Anybody else? Okay. Okay, let's go to next slide. So terms involved in motion. Suppose, so actually, when a body is in motion, so when it is moving, what terms we will come across? Suppose a body is here. Suppose a body is at position A. A body is at position A. It moved up to position B. So first we will come across a term called position. So then from A to B, it has covered some length. So the length, actual length covered by the body, we call it as distance. Actual length covered by body, we call it as distance. Or suppose this is the actual length. This is actual length is called as distance. We come across distance. So this is the shortest length. Shortest length we call it as displacement. Means for covering this length, it might have taken some time. It might have taken some time. So this much distance, it has covered in some time. So distance by time means how much distance covered in how much time. This ratio is called speed. This ratio is called speed. Suppose if the distance happened in one particular direction, then we call it as displacement S. It happened in how much time? T time. So this ratio is called velocity. This ratio is called velocity. So while moving, like a bike, when we are moving on the bike, what happens? If we raise the accelerator, the bike speed will increase or bike velocity will increase. The increase of velocity, we call it as acceleration. Acceleration means change in velocity, increase of velocity. Suppose if we apply brake, what happens to that velocity? That velocity will decrease, which means retardation, or another name deceleration. So these are the basic terms. Which we will come across while studying about the movement of a body or while studying about the motion of a body. Initially, the body will be at a position. If we apply force, the body will move. It may move like this or it may move in straight line. If this is the actual path covered by the body is called distance. The shortest path is called displacement. The distance or displacement will happen in some time. So distance by time is called speed. Displacement by time is called velocity. Increase of velocity is called acceleration. Decrease of velocity is called retardation. So we will come across all this terminology when a body is in motion. So let's discuss term by term from the next slides. Okay. Do you have any doubt, ma? So what is velocity? Velocity means rate of change of displacement. Rate of change of displacement means in how much time, how much displacement done by the body. Okay, it will come in next slide. The complete definition of velocity will come in next slide. With example at that time, I'll tell you. So next. So distance travel and displacement. So here, if you observe here, this is the starting point. 1 minute. This is the starting point. So from the starting point, one object is moving like this, like this, like this in different directions, and finally it is coming to this position, end position. So here, so then what is the distance traveled by this body? Distance means the actual length. Distance means the actual length. The actual length of the path. The actual length of the path covered by the moving body, irrespective of the direction. It is called distance, because from starting point, this is the actual path. This is the actual path. How to measure the length of curved line? With the help of thread. With the help of thread, we can measure the length of a curved line. If we place thread on this curved line, after that, if we take it out and keep it on a scale in straight line, so then we will get the length of the curved line. So this actual length is called distance. While calculating distance, we won't consider direction, because its value we will find out irrespective of direction. Irrespective of direction. In this case, what is displacement? If anybody asks displacement, this is the starting point, this is the ending point. The shortest possible path means 2 points we have to join by a straight line. 2 points we have to join by a straight line. So then it is called displacement. So displacement will have direction. Displacement will have direction. Let's see another example. Here also same. Here also same. Here A to B. A to B, this curved path. This curved path is considered as distance. A to B, straight line, shortest possible path. This is considered as displacement. Means when a body moves from one point to other point, the actual length is called distance. Straight line path or shortest possible path between the initial means starting, and final means ending. Initial position, final position, shortest possible path is called displacement. So you can understand by this example, one student, he has to go to school. He went from point A. He started from point A. First he went to his friend's house, which is at 10 meters away. From there, both of them went to school, which is at position C. From friend's house, the school is at a distance of 5 meters. After completion of school, the boy returned to his home, starting point A or initial position A, which is 6 meters from school. In this example, so what is distance? Distance means how much ground object has covered. So this is the entire path the object has covered in this direction, in this direction, in this direction. Direction changing continuously. So distance is a scalar quantity, means a quantity which has only value, no direction. When we have different directions, we have to tell no direction, because as the direction is not fixed, we can't take any direction. So distance never depends on direction, so it is a scalar. How much distance is it has covered? 10 meter, 5 meter, 15 meter plus 6 meter, 21 meter is the distance covered by the boy. Whereas displacement, here displacement means, so he started from A, he started from position A, finally he came back to position A. So means there is no change in the position from beginning point to ending point. So his displacement is 0 meter. His displacement is 0 meter according to according to these values, because both are same. So here displacement depends on direction, so it is called as a vector quantity. Suppose if a object moves 4 meter forward, 6 meter backward, so then what we can tell, this is plus 4. This direction, this value is taken as plus 4 as it is moving forward. This value is taken as minus 6 meter because it is backward. So what is the displacement? Final position to ending position. We have to add both. So what is the value? Minus 2 meter. Minus 2 meter means from the starting point where he is finally, he is 2 meter backwards. He went 4 meter forward, 6 meter backward. But this is the starting point. According to starting point where he is finally 2 meter backward. So displacement depend on vectors. So some directions are taken as positive, opposite directions are taken as negative. Okay. So next. So here distance is a scalar because it has only magnitude, means it has only value, it has no direction. Displacement is a vector. Why? Means it has both magnitude and direction. Okay, distance can never be 0. Distance can never be 0, but displacement, it can be 0. Okay, we will continue this topic in next slide, because this distance and displacement only we will be going to explain in our next topic also. Okay, no need to worry. In tomorrow's class, we will continue the same topic. Okay. So here, if you want to, 1 minute. So if you want to, find out the recorded sessions or live classes schedules, you can go to our website www.aimstoday.in. There you can find the live class schedules and recorded videos and other notifications. Okay. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Have a good day.